Welcome to lesson 4.03, which is about MACC analysis in LEAP. In this video, we will be talking about MACC curves in LEAP and what MACC curves are and how we get prerequisites for MACC results. We will show MACC results and how to maybe utilize that in a policy setting. MACC curves are marginal cost abatement curves. These are originally from McKinsey reporting, but is a practical tool to show policymakers the different effects of our different policies in terms of abatement of, for instance, greenhouse gases or PM2.5 or similar compared to their cost. So it is basically this chart of squares where the vertical axis, or depending on where you are, we can see 0 is here in the middle. So in this case, we'll just take that down. So in this case, we can see what are the cost. Upwards. What is the cost of the policy? And of course, since we are under 0, it's a benefit, minus cost. So cost going upwards. That's on the y-axis, and then on the wideness of the individual box or the individual policy is its abatement potential. So in terms of how to read this chart, we can basically see the wideness of a certain policy is how good is it at achieving the goals that we want. How tall is it? It defines in terms of depending on whether it's in a plus or minus. What is the cost per? What is the effectiveness, efficiency of this policy in terms of cost per ton GHG, for instance, and then the entire area is the total cost of the policy itself. So, for instance, now here that I marked C&D buses, it will both be a good profitable policy in terms of our cost, and because it both fulfills a good demand, it abates well, but it also has a high negative cost per unit, and those two multiplied is the negative cost overall. So it's a very good, effective, and efficient policy. If we look for something like this, gas and renewable instead, we can see that the benefit is quite a lot less, but the abatement is quite a lot more. So the total area, I think in this case is about a third of the other one, is the total cost of this or total benefit. So we will not get nearly as big as a benefit per what we do in the policy, maybe the investment, but it is still still a benefit, and it has a very large potential. If you look at something like this over here, which I think is the biogas digestion in this case, we can see we are actually over 0, so we do have a cost, and we have very, very, very little wideness of this rectangle, which means we have a very, very low cost, very, very low abatement potential. So basically, this policy, when we see something like this, means it is not recommended because it is very, very inefficient in terms of policy and also very ineffective as a policy. So that's how we read these. In LEAP, there are two types of MACC curves that we have. We have the partial MACC curves, and that means when we see this chart, each of the policies are ranked independently, and it totally ignores the interdependence that could be. For instance, if you are investing in renewables and at the same time have a high implementation of electric vehicles of any sort, these will have quite a high interplay between them that will have a bigger benefit for both of them. There might be a much better offset for your renewables, your intermittent renewables, if you have anything like smart charging from your vehicles. But on the other hand, the abatement benefits of your electric vehicles is far higher when you have clean renewable electricity production. It's quite fast and simple. We just calculate the scenarios as per usual. But this also lends to misinterpretation. For instance, the cost and lack of abatement potential of BEVs if your electricity supply in the same scenario is just based on coal, while you have another scenario where we have policy scenario where we have renewable energy that actually could interplay. That's where the retrospective MACC curve comes in. That takes account of the interdependence between the different policies, but we do have to calculate the model each time for each policy, because then it calculates everything but the policies, all the different policies first, and then see how much it benefits the policy we are working on. So for instance, for the CNG buses, in the partial MACC, we just consume some natural gas. Our power might be produced by any other sources, while in the retrospective MACC, we might also have a interdependence on investments in natural gas supply that is then benefiting these buses, because natural gas then becomes cheaper as a fuel. So that's a method we can do that. So let's just talk quickly about prerequisites for doing MACC curves. So because the MACC curves have to recalculate with different scenarios, or recalculate the model for each scenario that's been analyzed or we want on the MACC curve, we cannot do it on optimization. It will take too long. It would be too complex. So there's no, there seems to be no MACC for optimized models. We need to include, of course, both effects and costs, so we can compare the two on the MACC chart. Of course, the abatement potential is all about effects, and of course, cost is all about cost. Then, if you remember from lesson 1, we were talking about main scenario and policy scenarios. And policy scenarios are where we have very few changes that are very specific to a certain policy that we then want to combine. That's what we use for MACC curves in terms of the policy analysis. We could do with larger scenarios, but there is not a real point in terms of comparing the effectiveness of these policies if they are just combined in big fossil and green scenarios, for instance. LEAP also cannot calculate combined scenarios, which is, the combination of several policy scenarios, as it needs to compare each of these policies, so combinations doesn't make sense. The whole retrospective part of LEAP's calculation also means if you want to separate out a certain interdependence, you will have to make a MACC curve for just these two separately, and then compare that to the other partial MACC curves, which is a bit of an unfortunate thing, but it's rarely used in this case. In a model where all the prerequisites are complied with, we can find the MACC curves in summaries here in the main menu. Here is a table for it, and then we can find the charts, which is a well-known MACC curves. As we can see in this case, we have quite a lot abatement potential for having CNG buses with a very big benefit as well. The same here, we have a very large abatement potential with some benefits by using gas and renewables in this model. It should be noted that we do not calculate the model when we go in here into summaries. So to actually show our MACC curves, we have to press on refresh MACC, which we will do now. This takes a little while because we calculate the model several times, in this case 6, because we have 6 different scenarios. So we have, for each of these policies, we have to compare them to each other when we want the MACC retrospective version. So that's what the model is doing now. And it takes about half a minute in this case for a smaller model. Now, if you have optimization where each scenario can take up to 10 minutes to calculate, we can also see that this would be a bit of a problem if we were doing MACC. Now we have a calculator. I didn't change anything. I haven't changed any data, so that's not surprising. So here we have MACC retrospective, where we can see how also the singular policies work in relation to each other. And here in the MACC partial, this is just how they work without any relation to each other. So the interesting thing here is that the C&T buses are, maybe you have to refresh MACC in this case as well, because we also have to refresh in this past one. It should change quite a lot. Good. So now here in partial, we can see it looks more or less the same. Actually, the biogas digestion, I think, has a lesser cost than it did before. But this is the policy scenarios just by itself calculated compared to the baseline. So this is so these does not take into account the benefits of, for instance, investing in natural gas while also converting all the buses to CNG if those two are in different scenarios.